Hello there, Evie here, and welcome to the Lian UNI FAN AL120 RGB fan. This is a bit of a strange product, and I think it's something that really speaks to those who prioritize minimalist or some sort of clean build with RGB, but not necessarily very quiet builds. You'll know what I mean as we go through. Disclaimer, this set of 3 fans and the controller was sent to me before release, not directly by Lian, but by a marketing company that works on their behalf. So I'm not 100% sure how to disclose that, but I think that should do. So there we go. So let's get into the meat of this product, which is the modular connection party trick. And this is why I refer to this being ideal for those really into clean builds. As much as people seem to like RGB lighting, the cables are a pain. Dealing with individual fan speed and lighting wires from a fan is okay, but the daisy chain ones add more bulk to the equation with the connectors and the extra wire that goes with it, which makes it more difficult to cable manage cleanly. And these allow a set of fans up to 4 in a row to connect together while only connecting back to your controller or your motherboard, more on that later, with only a couple of leads from one fan, one for ARGB and one for fan speed control. In terms of actually connecting these fans together, it's simply a case of aligning the notches and slotting them together. This marries a set of pins from one fan with a set of pads on the other, which daisy chains the ground, voltage, sense and pulse signals from one fan to the other, getting rid of the fiddly daisy chain wire I alluded to earlier. The link is smooth and doesn't require a huge amount of force to remove, which helps to make it feel solid and well manufactured. They can even be connected and disconnected while active, not something that anyone's gonna do in the real world, but the extra sudden load of even 2 additional fans didn't seem to trigger any sort of overcurrent protection on my NZXT grid, not the thing I'm using with this right now, which is nice to know since the load of even one of my older 2200 RPM EK Vada fans constantly causes that thing to seize up or crash. That probably has more to do with the older EK fans than these, but there we go. This isn't the first fan to do this party trick. Lian also have the SL range that's similar but more frame RGB and less, well, blade RGB. Before we move on from the connection situation, I think the link connector thing on the main cables that link the fans to your controller or your motherboard feel a little cheap. I think this feeling stems from the large size and the very light weight of them. There's a lack of density there, and I think density, correlates to quality feeling to some degree. I'm not sure there's a lot that we can do to change this. Why add weight when it's not necessary, and reducing their size would likely reduce their connection strength. Not a big deal by any stretch, the connection is solid and it's a one-time thing you'll do, so there's not really much to complain about. The fans themselves are, as far as I'm concerned, the most stylish fans I've had my hands on. That's not to say they're the most stylish or visually polished fans around, that's up to you. But when the back of the hub has been dressed to tie in with the style of the front, and the spokes have been designed to mask and match the wires to the hub, which are also coloured to match the frame while remaining hollow, we're clearly looking at a level of attention to detail that most fans just don't have. This also means that I can't read the specs of the fan from the back of the hub, but you can have the inside of your system look as polished as the outside. You win some, you lose some, I guess. We've also got some semi-gloss aluminium strips to the sides. Before I move away from the fans, you as I might also be wondering how a row of these conjoined fans align on a radiator, and that's a damn good question. What if they're slightly misaligned? What if an error stacks up in terms of tolerance that will cause a fan on the end to be unsupported because the screw through the fan won't align with the radiator properly? Well, this has been thought of and the issue has been designed out. If you look closely at the corner of the fans, you'll notice there's a slightly skewed hole, which accounts for the tolerance of radiator mounting holes, while still being usable when fixed with regular fan screws to a chassis. It's a really simple solution to an awkward problem and is equally clever in its simplicity. And it's a good job that they solved that problem. It would have sucked if they were to drag down the cool connection from the overall design. But I will say that when you remove the fan screw holes, that you can see how it connects. It only holds on to the flat edges, so maybe not the strongest mounting strength, I guess, but strong enough. It is just a fan after all. I did completely gloss over, actually skipped over the unboxing, so let's get all you need to know from that. We have a box. It contains many cables, but also many fans and some paper. One piece of paper holds the physical installation guide going through the controller and fan hookup details, and the other piece of paper is all about the software side of things. This is where I feel compelled to say, well done to Lian Li. This is such a comprehensive resource of guidance for just the software, and far surpasses that of companies like NZXT and their CAM software. Moving on to the cables and the box, as alluded to before, is the controller for these fans. You don't need to connect the fans to the controller to use them, but you'll need an extra set of adapter cables to convert the RGB connection, which isn't included in the box. And yes, Lian Li sells them to you. This, to me, is a drag. Sure, the smaller connector type might save some space on the controller, making it a bit smaller, but if you've got to add the cables within this cable reducing system, that kind of erodes the effect of the cable reducing system. I think they should be the very standard 3-pin J rainbow connector by default, and bypassing all the nonsense. That'll also bypass the requirement for a converter from the 3-pin to the 3-pin J rainbow connector thing. Anyway, that would bypass all this nonsense. If you connect directly with the board, you can use them as you would any ARGB lighting device with software of your choosing, probably from your motherboard's manufacturer. I'll leave a link in the video description to Lian Li's video with more details, or more specific details on that kind of thing. Or you can link them all to the control box and use the Lian Li L-Connect software. I'll show you a quick rundown of what you can expect to do in the L-Connect software, but I couldn't get this to work with my old Z170 board since it doesn't have any LED lighting support whatsoever, let alone ARGB. It does the rainbow effect by default though, so at least we can look at that. Regarding the L-Connect software and the control you can get over these fans, it's quite in-depth and gives you a lot of synchronization features with any colors you want. You've also got a range of fan control or speed options, and it looks like the PWM option is dictated by the PWM signal from your board, hence the fan connector with just the one wire. You can control up to 16 fans at a time, 4 per each of the connections to the box, and for the sync effects, you've got a grid to dictate how many fans are connected to each header to control the sync effect timing. I've got a single fan connected to 3 of the inputs on this controller, and there's nothing to register how many are connected, and it's not smart, so you'll have to plan it out or trial and error doing the setup. It is numbered on the box, so you can figure it out that way. If you're using pretty much anything between my 5-generation old test system and the boards out now, you'll likely have support for all of this. Just make sure your board has a 3-pin J rainbow 5-volt connector that looks like this. I was really hoping I could forego the ARGB connection to the board and just have the lighting controlled via the box with the L-Connect software, but that support doesn't appear to be implemented here. At least I couldn't get it to work, which makes these a little less compatible than NZXT's hardware with CAM and Corsair's Commander Pro or other ones with IQ. But for now, most boards around at this point will likely have this support or compatibility, so it probably won't be an issue for you. Now let's talk fan performance. I will be comparing the performance of these UNI FAN AL120s with Noctua's NF-F12 Chromax fans and some fairly old EK FL120 ERs. I wanted to create some sort of airflow profile for these fans in my reviews, or my fan reviews, and I managed to create this top-down view of how fast the airflow of the AL120s were at full speed across an array of distances and offsets from the center. Unfortunately, I had a higher width resolution than the depth resolution, which distorts the appearance of the airflow profile, and my attempt to resolve this, well, it just took too long to create in a way that I was happy with, so I gave up. if there was any chance of me actually creating this video on time as well, then some compromises had to be made. Instead, I decided to measure the airflow of each fan in 5% increments at a distance of 10 centimeters from the center of the fan blades, the blade bit, not the hub as well, which appears to be the highest airflow sweet spot of fans. I also measured the noise level of the fans at a distance of 20 centimeters at an angle of 45 degrees, so it's out of the cone of airflow to prevent distortion. So what did this faffing around result in? Well, plotting fan speed percentage versus RPM, the Uni fans cannot spin slower than just over 800 RPM, whereas the old EK fans can spin down to just under 600 RPM, and the Noctuas, which I've lost, can go all the way down to just over 200 RPM, which is pretty nuts. The Lian fan that I tested can spin up to around 1850 RPM, which is a touch slower than the 2100 plus RPM from the EK fans, and a touch faster than the Noctua fan at just over 1600 RPM. So we should expect the following results of the Lian fan to be in the middle of the others at full speed, all else being equal. Just before I switch over to the noise level chart versus the fan speed percentage, note that the Lian Uni fan spins at 800 RPM up to 50% and then increases in speed. So switching over to the noise level, you can see at 50% the Lian fans are slightly quieter than the other fans, but are louder below 40% fan speed. Now, this appears like the 800 RPM lower limit doesn't make much of a difference, but that's completely misleading. The Lian fans are louder than the noise floor, and it is noticeable. Something that's a little strange is from the 65 to 90% fan speed, the Noctua and EK fans have some weird noise level changes, not proportional to the RPM of the fans, which is pretty linear. The Lian fans created a very smooth noise level ramp up, and although they spun faster than the Noctuas, they weren't much louder at the top end. Now, I will say the tone of the Lian fans were a little higher in pitch, which I found to be more annoying than the Noctuas, but not as annoying as the much louder EK fans. Unfortunately, I can't accurately represent tone, so I'll just leave it at that, just an anecdotal comment. And finally, onto airspeed. This is super important, and I think this is why I don't recommend the Lian fans for quiet or silent builds. Below 50%, they are higher than the noise floor of the room, and they're still generating a lot of airflow. And at the high end, they're producing airflow proportional to the fan speed. The EKs follow that proportional trend all the way down, falling below the noise floor of the room, and the Noctuas kept spinning all the way down to 15%, which was well below the lower capabilities of my budget anemometer and the noise floor of the room, hence the fudgery from 15 to 30% on the Noctua line. So that's the profile of these fans dealt with. Let's talk thermal performance in a real world scenario, or a couple of them. To do this, I needed to come up with a test chassis of sorts, something that could hold 3 fans, potentially 140mm fans in the future, and ideally provide the ability to test higher airflow and lower airflow resistance. To achieve this, I dug up the Antec DP301M Dark Phantom case, a case I never got round to selling, and luckily so, since it's got quite a small intake to the front panel for higher resistance, low airflow testing, and the front panel can be removed for lower resistance testing while retaining a filter similar to a high airflow case, much like, say, the Lian Lancool 2 Mesh or something. In terms of the fan setup, we're using the typical 2 front intake and 1 rear exhaust configuration, and I'll be using the same Firestrike combined looping 10-minute benchmark for the system load throughout that I use in my case and fan testing. I'll also be case and cooler testing. I'll also be testing the fans at full speed and noise normalized speeds to 36.5 dBA to get an all-round grasp on how they perform in different setups at different speeds and normalized thing. So, how did the different fans compare? Starting with the low airflow and noise normalized setup, the Noctua NF F12, Lian Uni FAN AL120, and the EK Vada F4120 ERs were all neck and neck. It appears when they're producing the same noise output at 36.5 dBA at 40 centimeters and that sort of thing, in a case that is restrictive, there's not a lot in it. It's interesting to note that the Noctua fans were spinning the slowest, followed by the AL120s and then the EK fans. Turning the fans up to full speed, keeping the front panel on, the EK fans managed to cool the GPU a little more, allowing it to clock a little higher than the other fans, but didn't manage to get the CPU any cooler. You might be a little bit confused about why I'm using GPU clock when I'm using CPU thermals, but it does make sense when you consider the GPU is always sort of thermal throttling or downclocking due to temperatures, and it's compensating for that increase in temperature by downclocking. So you get variance in the CPU temperature, but it's always having to downclock in order to compensate for the rise in temperatures. So that's the useful metric. Anyway, this isn't a surprise since the EK fans were spinning noticeably faster than the others while being noticeably louder. The Lian AL120s falling right in the middle of the other two in both fan speed and noise output. How about reducing the air resistance of the case and removing that front panel? With the noise normalized level testing, this saw the Noctua NF F12s jump ahead of the others with a better CPU thermal result, but not much of an improvement on GPU thermal results or GPU clock results in comparison. The AL120s finished last here, but not by a large margin, and frankly within tolerance of the EK fans. Again, Noctua fans were the slowest in the noise normalized setup, which indicates perhaps the blade design is a little more aggressive than the competition. Whatever it is, it's working for them. And last but by no means least, the high airflow full speed results. Again, Noctuas are ahead, but not by much, and the Lian AL120s and EK Vardas follow closely behind, but neck and neck with each other. Now, for a conclusion, what reason or shouldn't you consider the Lian AL120s? I've mentioned a few times already, but you should avoid these like the plague if you're looking for a super quiet build. I mean, they are quiet, but they're not like silent. They're not really loud by any stretch, but if you're just browsing the web and you don't want aggressive cooling at that kind of load, they're going to be hitting above 800 RPM, and that's close to the speed that some fans top off at. I know the Q300L's case fan is an 1000 RPM fan, and those go to 800 minimum, so that might give you an idea. But if you're looking for something ARGB in a clean build, I don't think there's much of a cleaner way of reducing the visibility of cables than reducing them in the equation. And the super smooth lighting transition of these fans really is top notch. And for that use case, these are something to consider. However, the retail for the SL120s, I don't know the price of the AL120s, but the SL120s is at £75 or $90 for 3 fans with the controller. And even within Lian's range of ARGB fans, that's nearly triple the cost of their lowest end ones. Now, they might actually be the same fans that came with the Lancool 2 mesh, so they could be 3-pin ones. Obviously, they're not to as high a spec of this, but just a point of reference. Just to better round off the cost part of the conclusion there, just to make this as fair as I can, for feature parity and the cheapest set of 3 fans with RGB fans with a controller from another quality vendor, like say Lian, you can get the Corsair IQ SP RGB Elite fans in a 3-pack with a controller for £50 to £55. It's about 30% cheaper than the Lian UNI FAN AL120 RGBs. Now, they don't have the polish, like the visual polish at least, that the Lian fans do. They don't have a nice front or back of the hub. Both of them are stickers. They don't have, say, aluminium side skirts, that kind of thing. They're just a simple ARGB fan. So, there is an argument for getting the Lian ones, but you are going to need to have deep pockets because you will be paying an extra £20, $30 just to have those nice touches and a Lian product. So unless you really want that aluminium side strips, the controller and the ALConnect software capabilities, you might want to consider something a little cheaper, and remember, ARGB ain't everything. So if you are considering these, please also consider supporting the channel and using the Amazon associate links in the video description. It gives a small kickback to me and really helps to improve and maintain the channel. I hope you really like this one. It's my first fan review, but with any luck, it gave you everything you could want to know about these things, minus the lighting effects as they show up on the fans. Sorry about that. I just couldn't get them working in time, and unfortunately that experimentation fell on me around the same time I had my second jab, and I was kind of out of it. A huge thanks to Lian and the marketing team that got in touch to get these things into my hands well before launch. It helps a huge amount to be able to be competitive in this way. Normally I'm not time competitive for access reasons, and I hope the conclusion doesn't rub anyone the wrong way. I can only call it as I see it. They are really nice, but deep pockets are required. And here is a jarring cut. I want to do a quick update section. I'll say thank you to the patrons in a second. I'll say thank you now as well. And if you want to support the channel in that way, please consider joining the Patreon. There'll be a link popping up in a second. So what I wanted to discuss is a rather fundamental change to the way initially it's going to be cases, but a fundamental change to the way I'm doing at least case reviews. I'm going to cut that off just in case it's causing any more background noise than necessary. So currently my case reviews are generally 25 to 30, maybe even more minutes of everything. Unboxing, overview, build, all that sort of stuff. What I'm going to do is split them into two videos. I'll explain why in a second, but the first video is going to be an unboxing, overview, some compatibility stuff, use cases, that kind of thing. And then the second video will be more on the compatibility side of the detail side of the compatibility stuff. It'll be the build, it'll be the statistics, performance, and my final thoughts, recommendations and stuff like that, and a proper conclusion. That'll be entitled a review. The first one probably won't be entitled overview, but it'll just be something more generic. Now, the reason for doing this is it takes me a long time. It takes me 2 weeks to, really all out get one of those videos from start to finish, and that is... I'd like to get more from that, and I think it'll be more beneficial for the channel to make an unboxing style video and an overview style video, which will be in as much quality and detail as a normal sort of section of that would be, and then to follow up with a second video which gets more AV techie videos out into the world. I want to keep the quality up because there's no point in sending more out into the world unless it is of a quality and standard that I'm happy with and that people would want to subscribe to and would be subscribing for. But I want to get more AV techie out into the world and make the most of the time I'm sort of using to make these videos. So that is the main reason. It kind of feels selfish in a way, but I kind of see it as if this channel is going to work and it's really going to it's going to be something I can do more often in the future, then I need to find ways to make it grow more and make it more sustainable, that sort of thing. So I hope that doesn't come across as too jarring. I hope it doesn't come across as too like cash grabby or anything. But I mean, you might have seen statistics yourself. You can even just check on Social Blade. I'll put a little pop up there or something. But the channel's been on a bit of a decline. It's kind of plateauing right now, and I think we're going to be heading towards an up. But I do need to make some changes to make that happen. Now, this is going to push the video towards a 40-minute video. I apologize for that, but hopefully that doesn't come across as problematic to you guys, and I hope you take it with sort of the best of intentions. I'm trying to do my best by you, but also by me. So anyway, back to the thank you for the Patreons. And last but not least, a big thanks to my supporters on Patreon. The weekly updates have been labouring a little lately, but we'll get back up to speed in the future once a lot of the background stuff has stabilised. Still yet to put up curtains in this room. But anyway, if you want to, please consider joining them and me in the pursuit to make this channel bigger and better than ever before and get your name in the credits with these guys. And that's a wrap. Thanks for tuning in for this one, and I'll catch you in the next one.